running compression tests, even small misalignment between platens can cause uneven loading, inaccurate results, or premature specimen failure. Spherically seated platens solve this problem by incorporating a convex spherical surface nested into a matching concave housing, allowing the platen to self-align up to 4 degrees. In this video, we'll show you how to set up spherically seated compression platens and how to use them to achieve either precise platen parallelism or uniform load distribution on non-parallel specimens. Typically, a spherically seated compression platen is paired with a rigid fixed platen. It's recommended to use the spherically seated platen as the upper platen and the rigid platen on the bottom. This setup is commonly used when testing materials such as concrete, metals, plastics, composites, and structural components, especially in applications where strict alignment requirements apply, such as NADCAP-controlled testing environments. To establish precise parallelism between platens, begin by installing the rigid compression platen on the bottom of the test frame. Once it's in position, tighten the check nut securely. Before installing the spherically seated platen, ensure the 4 locking screws are loose to allow free self-alignment. Once installed in the upper connection, tighten the check nut. To align the platens, use the frame handset to jog the crosshead downward while closely monitoring movement. If your system has a micro-jog function, use it to continue lowering the crosshead until the platens just make contact and a small compressive load is detected. As a working guideline, apply a seating load of approximately 1/1000th of the load cell capacity. For example, 50 newtons on a 50 kilonewton load cell. Do not exceed 5% of load cell capacity during this step, as overloading can cause damage. Once the target load is reached, tighten the 4 locking screws on the spherical seat. The upper platen is now locked into the precise parallel alignment with the lower platen and ready for testing. If your specimen surfaces are not perfectly parallel, such as concrete cylinders or irregular components, you'll want to leave the 4 locking screws loose during the test. Install both platens the same way as before, then place the specimen between them. In this method, the spherically seated platen remains unlocked throughout the test, allowing it to self-align onto the specimen's surface. As the platens are driven onto the specimen, the upper platen adjusts naturally, conforming to the specimen surface and distributing the load uniformly. In the Blue Hill method, apply a small preload, no more than 10% of your expected peak load, to confirm the upper platen is making contact with the specimen before the test begins. The spherical seat is engineered so this adjustment occurs without lateral movement, ensuring consistent axial loading and accurate results. That covers the 2 primary setup methods for spherically seated compression platens, whether you need precise platen parallelism or uniform loading on non-parallel specimens. For more setup guidance and application tips, subscribe to our YouTube channel and visit Instron.com. Thanks for watching.